So we talked in the previous video about problems that were multiplications or they were already factored for you. But when we hit number 7, you can see that the problems are no longer factored, and you're going to have to do that extra step because x squared minus 1 and x plus 1 are not the same quantity. They don't have the same value. So you have to do a factoring step to get it done. Now, if you need to go back and do a factoring refresher, I'm going to try to record one of those videos for you today as well, just kind of a refresher. But I'm going to assume you already know how to factor, and I'm just going to go forward. So this is a difference of perfect squares. So a pair of numbers that multiply to -1 but add up to 0. So we would have x plus 1 times x minus 1. Remember this, they have to be conjugates in order to get no O and I, or to only get a binomial when you multiply instead of a trinomial. Denominator doesn't need to be factored, we just need to put parentheses around it so our eyes don't get confused. And now that everything is multiplication, right? A quantity times a quantity over a quantity, now we can do our simplifying. So that x plus 1 over x plus 1 becomes 1. And my final answer is just x minus 1 over 1. That goes invisible. Don't forget about factoring out a greatest common factor, like in number 8. So that you cannot, bad step, to cross out 7x and 7x and make it a 1, cross off 42 and 42, make it -1. No, these are quantities. So if it helps your eyes, put parentheses around them from the beginning. And then you have to change it so it's a multiplication so you can simplify. You cannot simplify with an addition or a subtraction. It has to be a multiplication. So let's change it. 7x and 42 are both divisible by 7. It becomes 7 over x plus 6. 7 times x plus 6. I think I misspoke. And then 7 times x minus 6. Now that we have multiplications, any quantities that are matching can become 1s, because I have to be able to multiply. So 7 over 7 becomes a 1. But x plus 6 and x minus 6 do not have the same value. So we cannot simplify those, and our answer is a fraction with the binomial x plus 6 in the numerator and the binomial x minus 6 in the denominator. Number 9 has both of these. Well, actually, it has a trinomial that needs to be factored, so let's do that one together as well. I think you've got the numerator. A squared minus 4 becomes the difference of perfect squares, so we need conjugates. A plus 2 times a minus 2. Now it's a multiplication, and we could simplify either part of that multiplication. In the denominator, we're looking for a pair of numbers that multiply to +6 and add to -5. So if you need your little box, they multiply to a +6, add to a -5. Hopefully you're seeing -2 and -3. So that a minus 2 times a minus 3. And now you can simplify. A minus 2 over a minus 2 becomes a 1. Notice the multiplication. A plus 2 times 1, that's just a plus 2. And 1 times a minus 3, that's just a minus 3. And that's all the further you can go, because those are the only multiplications that can be simplified. These are additions and subtractions. They cannot be simplified any further. Okay, I believe the next set you can try on your own. Yep, there are a bunch of examples. So watch out for greatest common factors in number 10. There's our GCF, or greatest common factor, and a unfoil factoring down below. And then I think in number 12 you kind of have some hidden work going on there. So give them a try, then come back and check your work. So I'm going to go ahead and work through these problems without talking too much about them so that you can kind of watch how the work goes, and I can put it in fast forward mode. So check your work and we'll talk about anything you had trouble with in class. I've got one more little bit after you check these. So the last bit we have to talk about is that sentence at the bottom of your notes. And it says that excluded values are numbers which cannot be substituted in for x because they will make the denominator equal to 0. These problems are intended to be very easy. There are some key words here. We said excluded values, and they make the denominator equal to 0. So if that's all the question asks for are only the excluded values, you can ignore everything in the numerator. That's the top part of the fraction. You need to factor the denominator and set each factor equal to 0 and solve for the x values. So that if we were looking at a problem, and let's just invent one. Let's put x squared minus 7x plus 3 over, I'm going to factor it for you already, so x minus 1 times x plus 2. If they're looking at this and the directions ask, what are the excluded values? All you have to do is say, okay, I could ignore the denominator, or I can ignore the numerator rather, so we're not worried about that in this problem because they didn't ask it for us. Didn't ask us to do anything else except what can't x be? X cannot be positive 1 because if I had x minus 1, if it suddenly became a 0, then the denominator is going to be 0 and that fraction is undefined. So x equal to 1 is the first excluded value. But we have a second factor in the denominator. It's x plus 2. So if we take that second factor and set it equal to 0, because that can't happen. We can't have 0 times anything gives us 0. So the second excluded value, the second one that causes an undefined denominator, is x equal to negative 2. Those are our two excluded values for that particular invented problem. Now some of the problems I think later in this work are going to ask you to simplify and find the excluded values. So you're going to have to factor everything. But after everything's factored, before you start simplifying, look at the denominator and do the same steps we did before so that you know which two values are the excluded values, and then finish by simplifying. So do the excluded values before you start reducing fractions. Excellent. See you in the next section.